Okay, for our last section of Unit 6, we're going to now talk about the properties of a kite and trapezoids. Our last two quadrilaterals in our quadrilateral hierarchy. There's another type of trapezoid we'll talk about, an isosceles trapezoid, which has all the same properties of a trapezoid, but a few additional ones. Let's start with a kite. A kite is a quadrilateral with exactly two pairs of congruent consecutive sides. And the word consecutive means right next to. So instead of opposite, consecutive means next to. And you can see right here, AB is congruent to AD, BC congruent to DC. Something else I'd like to point out, these angles right here, A and C, these are called our vertex angles. Okay, and the vertex angles are where those congruent sides meet. So A and C are called vertex angles. Okay, and you'll see more of those. And they have a few other properties that we're going to list down below here. Okay. Vertex angles of a kite formed by the two congruent sides right where they meet. The other angles would just be called our non-vertex angles. That would be B and D. All right, two theorems we're going to list here. This first one involves the diagonals. Hopefully you can see just like a rhombus, and that's why these two are connected, kite and rhombus. The diagonals are perpendicular, so if a quadrilateral is a kite, then its diagonals are perpendicular. Right, and that is the same as a rhombus, which is why those are connected on our family tree. Something else I want to point out here that I'd like to add next to this diagram. The diagonals also have two other properties that we need to list on here, okay? The diagonal also bisects a pair of opposite angles, okay? So I'll just make note right here that one diagonal bisects both of the vertex angles, splits them in half. And then this diagonal also bisects the other diagonal. So the non-vertex angle diagonal is bisected. Which means this half is congruent to this half. So two additional properties of your diagonals here. There's really three we talked about, right? The first one being this diagonals meet at 90-degree angles. One diagonal bisects both of its vertex angles, and then the non-vertex angle diagonal is bisected. Okay, and we'll talk more about those properties when we're solving for some measures in just a sec here. Our last property involves one pair of opposite angles. So if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. And those opposite angles are your vertex angles. They're always going to be congruent. As you can see, K and M, those are our vertex angles. Or I'm sorry, non-vertex angles. Let me fix that. Non-vertex angles. These are our non-vertex angles because they meet at the two sides that have different lengths, right? J and L are the vertex angles because those meet where the two congruent sides are, all right? So be careful there. Okay. 4 properties that we just listed up above that we're going to use down here to solve for the missing measures in this kite. All right, let's fill in everything that we know. Angle FEJ is 25 degrees. It's this angle right here. FGJ is 57. Zoom in a little bit here. 57 degrees. We know that this is a 90-degree angle, so we can list that on there. And we want to find GFJ, which is right here. We also want to find JFE, here. And then we want to find GHE, this whole angle. Okay. Let's first start with this purple angle here, GFJ. Well, if we have an angle measure that's 57, then we know that this angle right here needs to add up to 90 with 57 because you have a 90-degree angle right here. So we would say 90 minus 57 gets us 33 degrees. And now you have 57, 90, 33. All 3 of those angles add up to 180 degrees. So you are good. Right? Okay, we can also find this green angle now using the same method. We have a 90-degree angle, 25. So we know that this other green angle needs to add to 90 with 25 because 90 plus 90 is 180. Subtract this, we get 65 degrees. So JFE is 65 degrees. And then this orange angle, this is the non-vertex angle. We just talked about this property. The non-vertex angle is congruent to its opposite angle. It's opposite non-vertex angle, which is 65 and 33, so 98 degrees. Okay, using all of those properties that we just listed up above. 2 examples down here, 2 more kites. Let's have you solve both. What I'll do with you is I'll go label everything that's given. For B, all the information is already there. You have this side length of 3.25 and this angle of 118 degrees. For C, kite PQRS, angle PQR, this whole angle is 78. Keep in mind that this diagonal bisects a pair of opposite angles. That might help you. And then TRS right here is 59 degrees. Okay. All right, go ahead and solve both. Starting with B, we'll check your answers when you're done. Okay, for B, angle D and angle B, these are the non-vertex angles. They're opposite of each other, so they were congruent. D was also 118 degrees. AB is the consecutive side with AD, so these were congruent, 3.25. And then CD, same thing. Consecutive sides are congruent, so this was 6. Sorry, I missed that. That was another measure that was given. All right, and C, a little bit more work here. QRT is right here. Well, you need to know that this was a 90-degree angle and that this diagonal bisects this angle, so it's going to split the 78 in half, which gives us 39 degrees. And then if we have 39, we can just subtract that from 90 to give us 51. For QPS was right here, this whole angle. Well, if we know that this angle up here is 51 and 59 is the adjacent angle, the whole entire opposite angle would need to be 51 plus 59 for 110 degrees. And then finally, PSR is right over here. You kind of need to use a few things to solve here. Find one of these angles, knowing that this is 90 again, right? So this angle has to add to 90 with 59, so that was going to be 31 degrees. And if that's 31, this is 31. Add them both together, get your 62, all right? All right, let's finish up talking about trapezoids. Trapezoid is a quadrilateral with exactly one pair of parallel sides. Just one pair of opposite sides that are parallel. See those right here. Okay, those are called your bases. The leg angles of a trapezoid are these are supplementary. Okay, because these are parallel, you can imagine this, just both of these legs. You can imagine these legs just being a transversal, and if a transversal intersects two parallel lines, then the two same side interior angles would be supplementary. So if this is x, this would be 180 minus x. We got that listed on there. Each pair of the parallel sides are called your bases, while the non-parallel sides are called the legs. If the legs of a trapezoid are congruent, then we have something called an isosceles trapezoid. If you remember isosceles triangle, two congruent sides. Same with a trapezoid. The legs of a trapezoid, if they're congruent, the non-parallel sides, then it's an isosceles trapezoid. Okay, let's list a few more theorems we have specifically for isosceles trapezoids. If a quadrilateral is an isosceles trapezoid, then each pair of base angles are congruent. Okay. Those base angles are the angles that are on the same side of your base. So A and D and B and C are both congruent. Remember, leg angles would be the two angles that are located on the side. So these two, and those are always supplementary. Okay, great. Second property involves the base angles again. So if a trapezoid has one pair of congruent base angles, then the trapezoid is isosceles. So just the inverse here. You have one pair of base angles, A and D being congruent, right? Those angles are located on the parallel. It's on one of the parallel sides. So then you have an isosceles trapezoid. Then we can assume that AB is congruent to CD. Just the inverse there. One last property involves the diagonals of an isosceles trapezoid. A trapezoid is isosceles only if its diagonals are congruent. All right, so our diagonals are congruent here. AC is congruent to BD. Okay, plenty of properties here that we're going to use to solve for some missing measures on our last page here. Starting, let's do example A. Let's do A and C together, and then you can try B and D on your own. For A, this is a base angle, 100 degrees, which means the other base, and this is an isosceles trapezoid, which means the other base angle has to also be 100 degrees. And the angles that are same side interior or leg angle would be 70, supplementary. So then the measure of A would also be 70 because it's a base angle with that side, 70 degrees. All right, let's try C. You have the diagonals listed here. We know that KB is 20 And we know that MF is 30, this whole thing. What's the length of FB? FB is just this length right here. Well, if you know the diagonals are congruent, you know the whole thing is 30, just this one part would have to be 10, 20, 20, 10, and 10. Diagonals are congruent in an isosceles trapezoid. All right, try B and D on your own. B, you're solving for the measure of angle F. D, you're solving for the length of KM, this whole diagonal. Go ahead. Okay, for B, again, E is a base angle. This is an isosceles trapezoid. You have the legs that are congruent. So then your base angles are congruent, 40 and 40. And then the leg angles are supplementary, which means F and G, they were both 140 degrees. For D, you know that JN is 10. You know that NL is 14. Okay, great. That means the length of the whole diagonal is 10 and 14. That's the same as the diagonal KM. Diagonals are congruent, so the length was just 24. Right. Then one last property to talk about for trapezoids. If you have a midsegment, we've talked about midsegments before with triangles. It's a segment that's connected to the two midpoints. For a trapezoid, the segments, it's the endpoints that are the midpoints of the legs. Okay. Well, the midsegment of a trapezoid, it has a property that involves the two bases, the two parallel sides. And that states that the midsegment of a trapezoid, and this is for any trapezoid, doesn't have to be isosceles, is parallel to each base. You can see that there. You have it marked up, parallel to each base. And its length is half the sum of the lengths of the bases. All right. So XY, that's our midsegment. It equals BC plus AD cut in half. It's the average of the lengths of the two bases. All right, let's do A and B together. For A, you have the lengths of the two bases, 8 and 10. So then EF is just going to be the average of the two. Add them both up, cut it in half. We get 20 divided by 2, which is 10. All right. How about for B? Now you're given the midsegment. So what I would do here is take this midsegment, just do the inverse. The midsegment doubled needs to be the sum of the two bases. So 16 times 2 is 32. So then this 25, and we'll call this X, needs to add up to 32. 25 plus what gets us 32? This has to be 7. When you're given the midsegment, do the opposite, just double it, and then find what length needs to be added to the other base to get you that number you found, the midsegment doubled. Okay, a lot of properties here, a lot of practice on the homework, last section of Unit 6, and then we'll start getting ready for the test next week.